Hello, everyone, and welcome to Real AI Now, a podcast about the real applications of AI in business, brought to you by TwoImpulse. My name is Marc, and I'm the product manager at TwoImpulse, and I'm your host of today's show. Today, this episode is going to be about simulation and supply chain management and AI in that context. Before I introduce our guest, I would like to ask you to subscribe to our podcast and leave us a like for this episode if you like it. This channel is available on YouTube, Spotify, Apple Podcasts, and Google Podcasts, and you will find the links in the description below. So today we have an incredible guest joining us. He's an industrial engineer with over 8 years of experience in supply chain management, specializing in network design, facility location, resource planning, simulation, and many more interesting topics around simulation. Yashar Ahmadov also pays close attention to the way you can deploy models at scale, which are usable by stakeholders. He has experience in cloud systems and in creating these scalable solutions, and he's using algorithms that provide results within reasonable time frame, making him a true innovator. So it's a pleasure to have you today, Yashar. Welcome.
Thank you, and likewise.
Yeah. So Yashar, as an expert in simulation and mathematical optimization, what is simulation and why is it important in supply chain management?
Well, first of all, we need to define simulation. Simulation refers to a broad collection of methods and applications to mimic the behavior of real systems, usually on a computer with appropriate software. So this is the official definition. In simple words, we are building the digital version or digital twin of the real life processes. And the underlying process can be anything, like with tangible outputs or intangible outputs, like in the service industry, in consulting, banking, and others. But it is more famous for its applications in the manufacturing industry, especially the processes that happen after the order is placed and until it's delivered. These processes are covered in simulations, and it adds value for doing what-if analysis. So let's say you have a manufacturing plant and you have 3 machinery located there on the shop floor. Now you're exploring, if I want to put 4th machine, how is it going to impact my production system? In theory, you can get a certain amount of throughput increase or efficiency improvement, but in real life, these systems, they work together with others and they interact with each other, and there can be processes that are linked to each other and very difficult to see it beforehand. This is where simulation comes into the play. In reality, if you want to simulate it, you need to go buy that expensive machine, put it there, and see how it works. But this allows you to do it in a computer environment, in a virtual environment. And if designed correctly, they can give you an accuracy of over 90%. And once you have built that, you can change a lot of factors, not only equipment. You can redesign your supply chain. So supply chain is all the path that a product takes from its supplier to an end customer. And that's why it's called supply chain. And there are many players in this industry. You're not alone. You only optimizing within your walls might not be enough for the global benefit of the supply chain.
So this digital twin would contain, so you mentioned digital twin, would contain a holistic view on not just your factory or plant, but beyond that, right?
Exactly. So if you have a supply chain that part of your raw materials come from another country, let's say from China, and let's say you have customers in North America, and you have productions in Europe, in North Africa. This is a global supply chain, and we need something more scientific to manage this complexity. And especially given the disruptions nowadays, especially the things that started after the COVID-19 pandemic, all these bring the industry to one conclusion. There is a better way of forecasting. Instead of trying to forecast what my next year going to look like, the smarter companies do scenario planning. What if these disruptions happen with a high probability? What if certain things happen with mid probability? What if certain risks happen with lower probability? You can prepare yourself for these scenarios by using the simulation models.
Yeah. This is something.
Yeah.
Sorry, I want to pick on this. So, I mean, failure modes and effects analysis, right, is probably a method which is known to most, right, and it's also one which has been around. What has changed? Because this sounds very similar to what has always been around. What is the novelty? What do you consider the change? Yeah.
So most of the simulation models allow stochastic modeling. That's different from several optimization algorithms, several different software. Here you can define a distribution. Instead of saying that I will receive an order of 10,000 pieces, you say my order is going to be distributed with mean 10,000 with a standard deviation of 2,000. And these simulations are able to run parallelly and give you a lot of replications. And as a result, it can give you, let's say, better or more robust approach into the problem. So as you said, these problems have been around for quite some time, and there are many different types of modeling or companies cracking their head on these problems. But the novelty is, again, first, the complexity that it is able to model. Secondly, the stochasticity, or allowing all aspects of the model to be stochastic or probabilistic, being able to run thousands of replications in a short period of time. This gives a much better view than using a deterministic method.
Okay. So what I'm curious about, I mean, the topic of this podcast is real AI application. Now, AI is also changing a bit the simulation landscape. What is, or how do you see AI changing the way simulation is being done nowadays?
I'm also a big fan, also a big believer on the potential of AI. And I think that more than 90% of the things that we do today will sooner or later be replaced by AI. As someone also who have worked with the neural networks, even during student times, to better understand the neural networks, our teachers were giving us exercises to solve it by hand. And when you do it, when you go into details of the beauty of the math, I came to the conclusion that there is ultimately very little thing that this modeling AI cannot do. Of course, now it's not in perfect shape, it's just starting. There are concerns which are also relevant, but affecting the world of simulations, I think for now the usage is you can ask ChatGPT about software, especially when you're modeling complex systems. You can ask for ideas, you can ask for code snippets. With the release of GPT-4, it can give pretty good direction to you to move forward in this type of modeling. For now, the usage is like that. The software that I'm using, they released a special edition saying that how can you use ChatGPT for optimizing your coding. You can release or reduce your development time a lot. You can reduce it by 30%, 50%. You know, before you needed to search on Stack Overflow, but now with one shot, it's giving you the answers. So for now, this is the impact, reducing the tedious or repetitive work. But as we move forward, I believe that these models would be able to model the complexity in simulations without human intervention. But we are still not yet there, because when I get the requirements for building a model, usually it is not very clear. Probably the stakeholder or the customer does not know either, or there are some problems that popping up as you start doing the modeling. There are things that are related to the data part, also data analysis, engineering, reliability part. So these are the things that AI models cannot do, but I'm not saying that it will stay like this forever. In the coming decades, we might be able to see AI models that can decipher those ambiguous requirements and probably build solutions. This is my view on the long-term development on this domain.
Okay. So I'm chunking your reasoning a bit into pieces. So I think one thing really, as a simulator, as a developer who's building simulation models, it can really help you accelerate your development, right? You generate code, you basically use it for troubleshooting, or like helping you be just more efficient. But on the other side, I mean, what comes to my mind, you mentioned what if analysis, right? So it helps you think of scenarios maybe you didn't come up with, or generate me, I don't know, 10 reasons this could go wrong, or things consider. And I've done this a bit in requirements engineering, and it always brings up these things, right? You don't come on the top of your mind, right? Which, yeah, should have maybe also included this. So you're seeing mainly AI as a way of helping you accelerate building simulations, but does it help you in kind of like running a simulation?
Running the simulation is not the most difficult part, because once you clearly model the things, it's just one click that you click on the run button. And then the job does not finish once you get the results either. You need to start making sense of the results. Is the model doing the right thing? These are two questions. Is the model doing the right thing? And is it doing things right? So two questions. That is also difficult at the moment for humans. But in the future, of course, these can also be one of the functionalities of AI, to be able to determine those.
Yeah. So let's imagine I do own a factory. I already have simulations, but I'm not super happy about the results. Where would you introduce these methods? What are like kind of like the steps you would take in making improvements using this kind of technology? So how to optimize your supply chain, for instance?
Yes. Do you mean using AI for this purpose, or in general the simulation?
Let's start with in general, and then let's start how you would. Let's continue how you would do this with AI.
Yes. So most of the simulation modeling software allow integration with different types of applications. Just like you might have a Python script that is doing mathematical optimization for you. You can call it from within a simulation, give it the inputs, and then collect the outputs. These things are possible. Potentially, at some time in the coming years, it can be automated with these language models also. But using AI is not very difficult in this case, because it's easier to integrate with outside applications. We do it at the moment. We integrate it with optimization algorithms. So as I said, simulation, you tell the configuration, and simulation will tell you if it's a good idea or bad idea. So simulation by itself is not going to optimize, or is not going to tell you that the best way or the cheapest way is to buy 100 tons from this supplier, ship it via vessels to a port in Spain, and from there you take it by trucks to the storage area. It doesn't tell you. The simulation doesn't do optimization. However, there is a possibility of integration, and where I think the AI can come into play, that in the course of simulation, you can make an API call to those those models ask questions like, this is the situation right now inside the simulation, because simulation has a time dimension. Let's say you are simulating 1 year, and there is a situation there that you need to make a buy decision. You can call an API, an AI model, and ask, this is the situation, what is the best thing that I can do? This is where I believe it can come into play. And in general, there are very strong optimization models developed throughout the last 50, 60 years. Also, there is a big advancement in the reinforcement learning domain, which is also facilitating this process. Like, you start a simulation, but simulation learns by itself by making decisions. It buys it from an expensive supplier with low quality, gets a penalty. And in the next time, it adjusts its behavior, that I did this mistake in the past, now I should do something better. And you train this reinforcement learning, which can by itself learn how to make the best decision.
Yeah. So for our listeners and viewers not familiar with reinforcement learning, it's a method in AI where you punish the agent if it does something bad, and like give it credit or a bonus kind of in case it does something good, and then lets it over time optimize for maximum kind of bonus, so to say. Yeah. So what you're describing, to me, it sounds, I think, very exciting. So what you're saying is that there needs to be an orchestrator, there needs to be a flow who is able to use different, let's say, optimization or simulation pieces and put it together to fulfill a certain flow, a certain result. And then they can be learning in different steps of that process.
Correct.
Yeah, okay. It's an interesting thought, because we had many discussions with clients who said, how can I use AI? How can I make use of it? I have this legacy things, and how can I introduce AI in my processes? And one of the most important things I usually do see is that you need to have a flexible architecture. You need to be able to also make use of novel technology, which is there, and try to avoid being stuck with your legacy or kind of like vendor locked in solutions. Would you say that the movement around open source and flexibility, and for instance, we see platforms like Hugging Face, where you really open source AI models, is something also being picked up in the domain of simulation?
Yes, simulation, although it's a very exciting field, it has not become a hype throughout the last years, despite its huge impact or huge potential on the businesses from the cost-saving perspective. It has not become that kind of hype that everybody is talking about it, writing about it. But of course, the simulation is also impacted by the developments in the bigger picture that is changing every aspect of the things that we do. Right now, what the companies are trying to do in this domain, they are trying to get themselves updated with the recent AI models and thinking about potential integration. But on the other side, there is no open source at the moment being published. There are few, but I want to make one clear distinction here. For simulation, there are some Python scripts or Java packages that they call a simulation. There are such open source things. One was released very recently, but it takes too much time to use that code. The best ones are coming with ready-made libraries that you can just drag and drop, and you don't deal with the back end of it, with debugging the code that is underneath it. So it hides some complexity with that. By using ready-made blocks, you just see one kind of visual rectangle.
No-code platforms.
Yeah. No code. It's low code or no code, this kind of thing. There are open source models for full code, which at the moment I don't see a huge potential due to the debugging, and you need to copy the code, and then if something does not go well, you don't have a big platform like Stack Overflow to ask the questions. There are some open source things like this, but moving forward, we might see some more advancements in this field. If AI starts to penetrate into this field and get some share, then we might see some changes in the behavior.
Yeah. So it's very much platform driven, and you want to empower the users to do their simulations quickly and get together, not waste time in, I don't know, writing glue code, in patching everything together. Yeah.
Yeah, okay. I'm willing to pay some money just not to deal with that debugging stuff. And likewise, things many companies and others. If I need to pay for a software that hides these problems for me, I would be more than happy, because the financial impact of the improvement models with the simulation is huge, depending on what industry, how big is your revenue. Even a small improvement project can easily justify that license price.
No, I think that makes perfect sense. So basically, innovating on the simulation and not spending time in running a platform, gluing everything together. So that's maybe an interesting point. So I wanted also to ask you, what are common pitfalls when getting into simulation and modeling? Maybe we mentioned one, building your own platform, but what are other things which come to mind, which you can give us advice what to avoid?
Yeah, so in simulation world, we have 3 different paradigms. One is called discrete event simulation, or DES. These were developed some 30 years ago, and there are some software that provides only that type of simulation, and it worked well for quite a long time. Discrete event, as the name implies, you give a certain configuration of the system, and then the system schedules events. So let's think of the logistics chain. Based on the configuration you gave, it says at t is equal to 0, a vessel will start moving from a Chinese port to San Francisco, for example. At t is equal to 5 days, it will reach its destination. And then at t's time is equal to 5.5, it will reach the warehouse. So it schedules events and just executes them. At the end, tells you this is the outcome. So it started well, but nowadays this has scalability problems. The discrete event simulations are harder to scale to more complexity or bigger supply chains, because due to its nature, if you get another let's say manufacturer into picture, you need to copy paste everything below, and it takes a lot of time to do this. And then what was released in some last 8 years is called agent-based simulation, which I prefer and I use it. Agent-based simulation is simply the same thing as object-oriented programming versus functional programming. It's exactly the same thing. In agent-based simulation, you define a high-level agent, let's say a manufacturer. And under it, you can have 100 different manufacturers, and those 100 manufacturers need not to be the same. You can still define different parameters, different sizes, capacities, location, latitude, longitude. But what it takes from you is you just create one main agent, and inside you define the behavior of that agent. Likewise,
every company would be one agent. They are just configured differently.
Yeah, and then from the inputs, you give its latitude, longitude information, its capacity, what products, and then several things like this simulation software had capability of geographic information systems like GIS. You give the location, it will read, and you don't need to tell it this is the transit time, this is the road. It automatically takes it from OpenStreetMap provider, and it again hides a lot of complexity for you. For those who start a simulation, I would suggest to have a look at the agent-based simulation because you start simple and it goes well with the same as discrete event simulation. But once you reach a certain threshold, you will feel that it's really difficult to scale those discrete event simulations, and there is no way back because you have already spent a lot of time to build that model. But to my opinion, till today, that I've been working with the simulations for my whole career, let's say 8 years, there haven't been anything that I could not implement with these agent-based simulations. So this is my first advice. Secondly, this is the same for machine learning, optimization, any kind of modeling. First, try to understand the business problem before jumping into solution. That's very important. And we all talk about this. Any developers, 70% of the time goes for understanding the input data, cleaning it, making it usable or consumable by the model. And this is true. You can aim for becoming a developer 100% of the time, but it's not going to be like that. You will still need to spend a lot of time in the things that are not directly related to the modeling. And it's better to first get good understanding of the problem, understand the data before promising anything to your customers. And then you can come up with proposal saying that this is the approach we propose, but we have these difficulties with the data, and we will need, let's say, an extra 1 month to put this into a correct shape. So these are the major things that I would suggest.
So the good advice of starting with really understanding the business problem and managing the expectation, then getting it right for the client, and then choosing the appropriate technology to simulate or to solve the problem, so to say. Yeah. I think it's one thing we also see a lot, right? So this jumping into solutions, technologies, frameworks, instead of really getting down to the problem and choosing the right tools, right?
Yeah, and the data is not clean. Never is clean. If you jump into solution, you will understand that it's not working, and then it's going to be a problem.
Okay. So how do you see, I mean, we spoke about simulations of one factory, right, or one plant, then also including your suppliers and maybe vendors and like the full ecosystem, so building an end-to-end digital twin. How do you ensure visibility and transparency into all the different moving parts, right? Because the complexity is exploding, right? You mentioned agent-based simulation. Anything more which helps in giving this transparency?
Yeah, so network problems are usually combinatorial optimization problems, which means that with the number of players, it explodes. Let's say you have 2 suppliers, 3 manufacturers, and 5 customers. Then how many combinations you have? 2 multiplied by 3 multiplied by 5. 30 possible combinations of shipping the products from origin to destination. But in real life cases, we have much more echelons. Thousands of potential suppliers, thousands of manufacturers, thousands of wholesalers, thousands of the retailers. The combinatorics is a big problem in this type of setups. But to tame the combinatorial problems, one can use certain abstractions. First of all, not all of those paths would make sense, right? There are certain things that will not make sense because you know beforehand it's much more expensive. So the thing is, you can eliminate the useless ones beforehand to reduce that complexity and feed it into your model. And it's all depends on what is the underlying software and where the bottleneck lies, because sometimes you think that it's the combinatorics that is the problem, but at the end, the things that increase runtime are something else. It can happen. So I would suggest use a profiler. Look where is the bottleneck of your model, which loops or which computations take a lot of time. Some unexpected things can happen because of the nature of the underlying programming language, some kind of numerical things that don't come to your mind can happen. So use a profiler. If you come to the conclusion that the complexity comes from the fact that we have exploding number of combinations, then you can use some strategies to reduce them into reasonable level. And also, during the course of simulations, you can tell the model the things that if it doesn't make sense, it can delete it out of the consideration. There is
so sorry for interrupting you. Yeah, so that again links to the point of like, speak to the client what is really important, because then you can discard some of these edges from your graph, right, which don't make sense.
Correct. Yeah. And then you have one question here about what you find most fascinating. I want to respond to that one.
Yes.
Simulation is one of the very few modeling types that allow visualization. Throughout the course of my career, I have built 2D and 3D simulation models. And what's its benefit? It takes 3 minutes to convey the message to your customer. They have a problem, they don't know the root cause. And I was building 2D simulation models of factories and their conveyors, their equipment. I was modeling their associates in a 3D shape, and then making sure that it's doing the correct things. With just one click, the management was sitting, and then instead of making them go through your complex model, you just open the slide and just show that animation. Okay, here is your current structure. If you do this, you see there is congestion and it's not working. You see these workers are staying idle, or there are upstream processes that are starving, all kinds of problems. It takes 2-3 minutes to show that animation and convey the message. This is the explainability side that I like about simulation modeling. You can build an AI model, and as you might know, there are questions about the explainability of the models. The more complex the model, it's harder to explain, right? If you build a deep learning model, you do hyperparameter optimization, and you deploy it. Now you give inputs and it's telling you the output. Explaining it to a person that's not coming from a technical field, it's really difficult, because why is it producing this result? Just because in back propagation, it's taking second, third derivatives of a complex mathematical function. And this certain weight is the one that reduces the total cost function. And people are like, okay, there is this concern, which there are also some startups addressing the explainability of AI models, which I find fascinating about simulation, is that sometimes it can take just literally a few minutes to convey the message.
So it's a bit, the picture says more than 1,000 words, right? So like once you put it in front of the eyes of the audience, they say, okay, well, that can't work because everybody has to go through this bottleneck kind of. So I think this is quite fascinating. What also fascinates me is a bit the possibility of also reverse engineering, right? So basically on volume numbers, right? Like just making it transparent how it looks like right now, right? And then this transparency really helps in saying, okay, well, this is what we need, right?
Yeah.
Okay. What worries you, or what scares you looking at AI technology and about the possibilities which open up, but also the risks associated to it?
Talking about general AI, I think this is also one of the hot topics nowadays. People are divided into two different categories. Some say it's a threat for the future. Some say it's an opportunity. I prefer to be among the people who see this as an opportunity to make our lives better, more efficient, get rid of all the daunting and repetitive tasks that AI can do. These are beautiful things, and looking to the future, it can already seem a good benefit, but I do share some of the worries about potential side effects of having AI models, also the ethics within the AI, the legislation. Countries are deciding now what to do with AI, the development. It can have some kind of side effects. So I'm not that kind of people who believe that one day all AI models will make a rebellion against humanity.
Take over the world.
Yeah, because first thing that makes me think about this is majority of the AI models will be just algorithms in the servers, right? It will not be a physical, like, in the movies like Armageddon. Majority of them will be just an app in the phone or in a server or in a computer. And if algorithm decides to do something against humanity, you can just take the battery out or remove the electricity. The problem would be if you had 1 billion metallic robots and all powered by AI, and after some point they get some sense of unity or try to do something against the people. And
the Hollywood way of depicting, right? The technology.
They have their own batteries, and then you can't really they make rifles or weapons that they don't let you come closer to their energy source. But this is, I think, a low probabilistic case. Nevertheless, I think it needs to be studied, well-regulated, ethics and its impact on the things. If we do this, I think AI will be a game changer in a positive way for the coming decades.
What do you think, getting back to simulation and getting back to the way how to optimize supply chains? We already spoke a bit about risk. What are the limitations of the current approaches? I mean, you mentioned compute, but that is kind of like covered with, let's say, about more cloud computing. There's also the topic of quantum computing. Where do you see the limitations maybe, and where do you see the field moving with regard to methods and technology?
I think technology-wise, we are in a good shape, especially with the cloud providers. We have access to, let's say, literally unlimited computing power. I don't think that's the bottleneck right now. Of course, if you decide to scale the solution and try to make money out of it, it might be becoming expensive for you, because cloud computing is great, but it's not cheap, especially if you have a huge customer base. That's not limitation, at least for the starting point. But this type of modeling has its inherent limitations. And the first one is, as I mentioned before, it does not optimize the things or tell you which way is better in the current phase. And if you want to find out what is the optimal decision to do, you might need to couple it with reinforcement learning or mathematical optimization models, right? And secondly, as any type of modeling, you can't model everything. Basically, you have a real life process. You need to abstract it and put a scope or boundary around it. And when you do this, you lose some accuracy versus the reality. And this you have to do because otherwise it becomes too complex. You can't take every single detail in the picture. These are the main things that I see as issues for now.
How do you see the paradigm? I'm getting back to quantum computing. And for instance, let's take the traveling salesman problem, right? Something which is NP hard nowadays. Do you see quantum computing, will we see it in, I don't know, a decade or so being say usable in simulation? What are your thoughts about this new way of compute?
Yeah. I also think that quantum computing can be used as a backend for computation. that can make your analysis faster, maybe a little bit cheaper. I see the potential in that way. I think it's already integratable with the available cloud services. You just go and buy that service, and then you can start running your models there. It's again cost versus benefit topic. If the problem that you are solving is around, let's say it involves 100,000 euros of total value, then it might not make sense to spend a lot of money on that. But if you are solving a huge problem with billion-euro impact, then why not?
Yeah. So what so we spoke a bit about the field of simulation. I also touched upon AI. Now there is a huge hype and energy around the topic, right? Like many people are fascinated by what's feasible. Some are scared. What would you advise a youngster, and I guess career advice, who wants to get into the topic of simulation and potentially AI? What would you recommend they should study, they should look into? What's important, what's not?
Yeah, I think there are some subjects that need to be obligatory in primary schools, or starting from primary schools. I think the coding, programming, children should start get sense of these, because in a very near future, many jobs will be wiped out, and the people who have the coding abilities, who are able to, let's say, upskill themselves will survive. So I think in order to start for simulation, it is a multidisciplinary subject. You need to have coding knowledge in Java or Python. Then, for example, I come from industrial engineering background, where we studied supply chains, all the topics that have their basis in statistics. I think statistics is the second key topic, that's a foundation of AI and machine learning. I would suggest to be very good at statistics and probability theory. And then at the universities, you can take different courses to specialize in different fields, because nowadays we need specialization. Because let's say 10 years ago, a data scientist, they would hire in banks, in logistics industry, manufacturer service industry. Now they are looking for specialized experience. Data science, yes, but in which field have you applied this? So it's better also to select some specialization, to think about it. Will you go for what makes you excited? Is it the manufacturing plant that BMW has with all the cars and the robots and warehouse management? Is this what is exciting you? Or is it service industry, maybe healthcare? There are also plenty of people who are interested in applying these knowledge in healthcare, because and it gives further, let's say, job satisfaction, because your job improves people's lives, right? You in hospitals, people come with health issues, or elderly people. If you are able to reduce their burden or waiting time for even some minutes, you are doing good for the people, right? To find your passion, which way you want to go, and try to learn that broader subject in the context of that industry. And hands-on experience is always important, as everywhere. And there are plenty of data out there, or by doing internships or getting into companies and getting your hands dirty. This is the most important thing.
So really getting your learning in various areas, and then specialize in one domain or industry you find your passion at.
Yeah.
Yashar, I think those are excellent final words. So I want to thank you for this interesting exchange, a lot of insights into AI and supply chain and simulation. Many thanks for being my guest today. Thank you.
Thanks to you, Mark and Sergio. to whole team. Thanks for having me. It was a pleasure speaking to you.
Thank you very much, Yashar. Then also to our listeners and viewers, I would like to also thank you for listening in. If you like this episode, please give us a thumbs up. And you can find our channel on Spotify, Google Podcasts, and Apple Podcasts. And for today, thank you very much for being here, Yashar, and thanks for listening in.
Thank you.